Now, please write down, sir, H.C.F. and its introduction. H.C.F. and its introduction. H.C.F. and its introduction. Listen carefully. H.C.F. stands for highest common factor. H.C.F. stands for highest common factor. Highest common factor. Now, before we explain what is a highest common factor, let us underline the keyword what is a factor. Suppose take a natural number. If I divide this with any other natural number and the remainder is 0, then x is a factor of n. X is a factor of n if you divide n by x and the remainder is 0. If you divide a number by any other number and you are getting the remainder 0, then that number is a factor of n. For example, remainder 1, 12 divided by x is 0. 12 divided by x is 0. So the meaning is x is a factor of 12. X is a factor of 12. What are the factors of 12? Factors of 12 are 1 is a factor of 12, 2 is a factor of 12, 3 is a factor of 12, 4 is a factor of 12, 6 is a factor of 12, and 12 is also a factor of 12. So what are the values that will take x? 1 it will take, 2 it will take, 3 it will take, 4 it will take, 6 it will take, and 12 it will take. When you divide a number by any other number and the remainder is 0, then that denominator is said to be a factor of numerator. Then that denominator is said to be a factor of numerator. X is a factor of 12. And another point, sir, how did you get these 1, 2, 3, 4, 6, 12 directly? First take 12. Write it out into prime bases. 2 6 are 12, 2 3s are 6. So 12 is nothing but 2 square into 3 power 1. 2 square into 3 power 1. 2 square is 4, 4 into 3, 12. Write all the powers of 2. 2 power 0, 2 power 1, 2 power 2. Write all the powers of 3 starting from 0 to 1. 2 power 0, 2 power 1, 2 power 2, 3 power 0, 3 power 1. Now, if you see here, 2 power 0 into 3 power 0, 1 ones are 1. 1 is a factor of 12. 2 power 0 into 3 power 1, 1 into 3, 3 is a factor of 12. 1 into 1, 1 into 2, 2 is a factor. 4 into 3, 12 is a factor. 4 into 1, 4 is a factor. 2 into 3, 6 is a factor. So 3 2s are totally 6 factors are there for 12. Anyway, in factors and multiples class, I am going to explain in detail how to write down all the factors of 12. How to write down all the factors of 12. Again, very, very important point. When you divide a number by any other number and the remainder is 0, then the denominator is said to be a factor of n. Then denominator is said to be a factor of n. Example, when 12 is divided by x, remainder is 0. So x is nothing but a factor of 12. X can be 1, x can be 2, x can be 3, x can be 4, x can be 6, x can be 12. Total 6 values are there for x. I hope the definition of factor is clear to you. Now, definition of factor is clear to you. Now, what do you mean by highest common factor? What is H.C.F? H.C.F is highest common factor. Highest common factor. Again, like we did it in LCM, H.C.F also we will do it in multiple methods. Method 1, generic method. Method 1, which is generic method. What is generic method? Generic method is a method which is there in our textbooks. N1 if I take 12, some natural number 12. N2 if I take 18, N1 is 12 and N2 is 18. Let us write down all the factors of 12. 1 is a factor of 12. 2 is a factor of 12. 3 is a factor of 12. 4 is a factor of 12. 6 is a factor of 12. 12 is a factor of 12. Similarly, what are all the factors for 18? 1 is a factor of 18. 2 is a factor of 18. 3 is a factor of 18. 6 is a factor of 18. 9 is a factor of 18. 18 is also a factor of 18. So first thing what we did is, we are moving from right to most, we took all the factors. Second step is, I will take common factors. I will take common factors. What are all common factors? Here 6 is common. Here 3 is common. Here 2 is common. Here 1 is common. 1 is common, 2 is common, 3 is common, 6 is common. This step is also over. Then find out the highest. Highest among 1, 2, 3 and 6 is 6. So the HCF of 12 comma 18 is 6. HCF of 12 comma 18 is 6. I hope the idea is clear. Method 1. Method 1 is, write down all the factors of that number and take the highest common factor. Take the highest common factor. A factor is also called as a divisor. A factor is also called as divisor. Why? Because 25 when divided by 5, 5 5s are 25, remainder is 0. Now if you see here, 25 is the number which is getting divided, so it is called a dividend. Number which is dividing the dividend is called a divisor. So 5 is called the divisor. Here how many times it is going? 5 times it is going, so it is a quotient and it is a remainder. And it is a remainder. Because 12 is perfectly divisible by 6 or 12 or 4 or 3 or 2 or 1. Any factor is also called the divisor. Common remains the common. Highest can also be said in synonym as greatest common divisor. So another synonym for HCF is GCD. GCD or HCF, both are synonyms to each other. HCF is highest common factor. HCF is highest common factor. It is also called as greatest common divisor. It is also called as greatest common divisor. I am not interested in this method 1. Method 1 is for us to understand each and every word in highest common factor. How to take factor, how to take common factor, how to take highest among the given factor. How to take the highest among the given factor. Definition of HCF and how to find out the HCF of two given numbers. Why HCF is also called greatest common divisor. Now, some important key points. Some important key points. Important key points. First one, HCF of 1 with any natural number. HCF of 1 with any natural number, it is always 1. HCF of 1 with any natural number, any natural numbers is also 1. Example, HCF of 1 comma 23, 1. HCF of 1 comma 24 comma 28, it is also 1. HCF of 1 with any natural number, it is 1. HCF of 1 with any natural number, it is 1. First point. Second point, HCF of co-prime numbers. Write down in the same order, sir. HCF of co-prime numbers, it is always 1. HCF of co-prime numbers is always 1. What do you mean by co-prime numbers? Only one factor common. Only one factor common, that is 1. If there is only one factor common and that is 1, then HCF of co-prime numbers is always 1. HCF of 1 with any natural number is 1. HCF of any co-prime numbers is always 1. For example, HCF of 5 comma 7 is 1. 5 comma 7 is 1. HCF of 12 comma 25 is 1. 12 comma 25 is 1. HCF of 17 comma 18 is 1. HCF of 17 comma 18 is 1. Now if you see here, why I took these examples, 5 is a prime number, 7 is a prime number. For a doublet to become a co-prime numbers, it is not mandatory that both the numbers should be prime numbers. Both are prime numbers. Both are composite numbers. One is a prime number, another is a composite number. Second important key point, HCF of any co-prime numbers is 1. HCF of any co-prime numbers is 1. HCF of 1 with any natural number is 1. HCF of 1 with any natural number is 1. All these key points I am going to solve it in problems. Very, very good questions you are going to solve it today, sir. HCF of co-prime numbers is always 1. HCF of co-prime numbers is always 1. Third one, third key point. HCF of any two consecutive HCF of any two consecutive natural numbers, it is always 1. HCF of any two consecutive natural numbers, HCF is always 1. For example, HCF of 31 comma 32. 31 and 32 are consecutive natural numbers. HCF is 1. HCF of 91 comma 99 comma 100. HCF of 91 comma 99 comma 100. 99 and 100. 99 and 100, they are two consecutive natural numbers. Consecutive natural numbers, HCF is 1. 1 with any natural number, again the answer is 1. HCF of any two consecutive natural numbers, HCF is 1. HCF of any two consecutive natural numbers, HCF is 1. Fourth point, HCF of any two consecutive even numbers. HCF of any two consecutive even numbers. HCF of any two consecutive even numbers is 2. You take any two consecutive even numbers, HCF will always be 2. Why it is 2? Why above should be 1? Everything we will discuss once I discuss congruent modulo theorem. HCF of 4 comma 6. 4 comma 6 are two consecutive even numbers, so it is 2. HCF of 24 comma 26. HCF of 24 and 26 is again 2. HCF of any two consecutive even numbers, any two consecutive even numbers, HCF it is 2. HCF it is 2. HCF of any two consecutive natural numbers, HCF of any two consecutive natural numbers, it is 1. It is two consecutive natural numbers, it is two consecutive even numbers. It is two, any two consecutive even numbers is 2. Suppose, next one, I hope it is clear. Some important key points. Any two consecutive natural numbers is 1. Any two consecutive even numbers is 2. Suppose if it is HCF of 15 comma 20. HCF of 18 comma 27 comma 36. HCF of 36 comma 48. HCF of 36 comma 48. HCF of 36 comma 48. What if the numbers are not co-prime to each other? What if the numbers are not co-prime to each other? What if the numbers are not co-prime to each other? How to find the HCF of the given numbers? What if the numbers are not co-prime to each other? Make them co-prime. HCF of 15 is 5 into 3. 20 is 5 into 4. Common number is 5. Take 5 out. 5 of HCF of 3 comma 4. HCF of co-primes is always 1. So 5 ones are 5. 5 ones are 5. Again, HCF of 18, 26 and 45 let us take. HCF of 18, 26 and 45, which is 9 2s are, next is 9 3s are, next is 9 5s are. 9 is common, taken out. HCF of 2, 3 and 5. 2, 3 and 5 are co-primes to each other. Co-prime numbers HCF is 1. 9 ones are 9. 9 ones are 9. I hope it is clear. Same like what we did it in LCM. First we will understand the definition of HCF. Then we will solve some very high quality problems. HCF of 36 comma 48. 12 into 3 comma 12 into 4. Take the factor common out. 12 is taken out. HCF of 3 comma 4. 3 comma 4 are co-primes. So 12 ones are 12. 12 ones are 12. If the numbers are not co-prime to each other, make them co-prime to each other. 5 3s are, 5 4s are. Take the factor common out. Take the factor common out. Take the factor common out. 9. HCF of 2 3 5 is 1. Take the factor common out. Take the factor common out. Now, I hope it is clear, right? What if the numbers are not co-prime to each other? Now listen carefully to every statement which I am saying after this slide. Side heading write down. Congruence. Congruence. Modulo theorem. Congruence. Modulo theorem. Congruence modulo theorem. Now see here. What is congruence modulo theorem? First I will take an example, then I will write the point. Suppose there are two natural numbers 5 and 7. Hypothetically, let us assume that there are two numbers 5 and 7. 5 and 7 are co-prime to each other. Co-prime numbers HCF is 1. First point. HCF of 5 and 7 is 1. Suppose I add these two numbers. 5 plus 7 is 12. If you observe, if 5 and 7 are co-prime to each other and their HCF is 1, 5 with 12 is also giving you HCF 1. Am I right? 5 with 12 is also giving you HCF 1. 7 with 12 also is giving you. 7 with 12 is also giving you HCF 1. Because if 5 and 7 are co-prime to each other, 5 and 12 are also co-prime to each other because there is only one factor common, that is 1. 7 and 12 also are co-prime to each other because there is only one factor common, that is 1. Now, let me do the subtraction. 7 minus 5 is 2. Now, if you observe, 2 and 5 are also co-prime to each other. So, 2 comma 5 is 1. Again, if I do 7 with 2, 2 comma 7 is also 1. 2 comma 7 is also 1. That means, what did you realize? If I take two numbers A and B, if both are congruent under some property, here the example is both are congruent under co-primes. If HCF of A comma B, if I got a value, it is also equivalent to HCF of A comma A plus B. Am I right? It is also equivalent to HCF of B comma A plus B. Am I right? It is also equivalent to HCF of A comma B minus A. Am I right? It is also equivalent to HCF of B comma B minus A. Am I right? If two numbers are congruent under some property, if two numbers are congruent under some property, even if you do modulo addition, the HCF value will not change. Even if you do modulo subtraction and do HCF with an individual number, HCF does not change. But if I do this both, which is A plus B and B minus A, what is HCF of 12 and 2? 12 and 2 HCF is 2. But according to the question, 5 comma 7 has to be 1. It is may or may not be equivalent to, may or may not be equivalent to A plus B and B minus A HCF. A plus B comma B minus A HCF. Listen carefully to my statement. Take two natural numbers A and B. A and B. A with the addition of two numbers. B with the addition of two numbers. HCF does not change. HCF does not change if you do HCF with sum of two numbers. HCF does not change if you do with a number with subtraction of two numbers. Individual number with the addition of two numbers, individual number with the subtraction of two numbers. HCF does not change. HCF does not change. If I do, it may or may not be same. Sometimes yes and sometimes no. Sometimes yes and sometimes no. I hope this point is extremely clear to you. See the heading, congruence modulo theorem. What do you mean by congruence modulo theorem? If two numbers are congruent under some property, modulo addition with individual numbers, modulo subtraction with individual numbers, congruency does not changes. Congruency does not changes. I will write neatly in the next slide. If A and B are congruent under some property, if A and B are congruent under some property, HCF of A comma B, it is also equivalent to HCF of A comma A plus B. It is also equivalent to HCF of B comma A plus B. It is also equivalent to HCF of A comma B minus A. It is also equivalent to B comma B minus A. May or may not be equivalent to, sometimes yes and sometimes no. So we will not write that. May or may not be equal to HCF of B plus A comma B minus A. Please make a note of this extremely important key point. Very, very important key point. If two numbers are congruent under some property, individual number with the addition of numbers, individual number with the subtraction of numbers, HCF will not change. I hope it is clear, right? If A and B are congruent under some property, let us take an example. Example, HCF of 15 comma 20. HCF of 15 comma 20. 15 and 20 HCF is 5. 15 and 20 HCF is 5. It is also equivalent to HCF of 15 plus 20 is 35. 15 35 HCF is 1. HCF of 15 comma 20 minus 15 is 5, which is also 1. Which is also 1. In this case, Naveen, congruency means, in the previous example, congruency could be anything where these two numbers satisfy some property. In the previous example, two numbers are co-prime numbers. So A and B are congruent under co-prime set. In the second example which I wrote, 15 and 20 are congruent under a set which is multiple of 5. Multiple of 5. So the congruency means they both will behave similarly under some property. I hope it is clear. A and B are congruent under some property. H.C.F of A comma B is A comma A plus B, B comma A plus B, A comma B minus A, B comma B minus A. Idea clear, right? Next important point. After this, we will solve a problem. We will solve a problem. Congruence modulo theorem. Is it clear? If it is clear, kindly keep it in live chat. Yes, 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 so that I can go to the next concept. What is congruence modulo theorem? If two numbers are congruent under a property, addition of two numbers with the individual numbers, subtraction of two numbers with the individual numbers, HCF does not change. HCF does not change. HCF does not change. I hope the idea is clear. Everybody kindly reply it in the live chat if it is clear to you. If it is clear to you, kindly reply it in the live chat. Right, everybody says clear. One more point. Right, largest factor method. Largest factor method. Largest factor method. Another way to do HCF, for finding HCF. Largest method, factor method for finding HCF. Largest factor method for finding HCF. Suppose HCF of 9 comma 12 is there. HCF of 9 comma 12 is there. Now 9 comma 12, how generally in our school days we will do? 9 ones are 9, remainder is 3, am I right? So we will check whether these 3 is dividing these 9. 3 3s are 9, remainder 0. So think logically, if this is B and it is A, what am I getting? B minus A. If B minus A, 3 3s are 9, remainder 0. So what you do is, method 1, take the factor of difference between numbers. Take the factor of difference between two numbers. Difference between two numbers. What is 12 minus 9? 3. So factor of 3. If I take factors of 3, 1 is a factor of 3. 3 is a factor of 3. Check for the largest number which will divide every number. 3 3s are 9. 3 4s are 12. Write the largest one. Write the largest one. Right? Take the difference between two numbers. 12 minus 9 is 3. Factor of 3 is 1 and 3. Check whether what is the largest number that will divide this number. 1 will divide 9, 1 will divide 12. 3 will divide 9, 3 will divide 12. But the largest number is 3. But the largest number is 3. I hope you got the idea. Right. Few more examples. Largest factor method for finding HCF. Largest factor method for finding HCF. HCF of 15 comma 25. HCF of 15 comma 25. Take the difference between the two numbers. 25 minus 15 is 10. What are all the factors of 10? 1 is a factor of 10, 2 is a factor of 10, 5 is a factor of 10, 10 is also a factor of 10. 10 is also a factor of 10. I hope it is clear. Now, if you see here, 15 is an odd number. 15 is an odd number. 25 is also an odd number. HCF of odd numbers. HCF of odd numbers is always an odd number. HCF of odd numbers is always an odd number. HCF of odd numbers is always an odd number. 10 is out, 2 is out. Check with 5. Is 15 divisible by 5? Yes. Is 25 divisible by 5? Yes. 1 also will divide 15, 1 also will divide 25. Largest number which we have to take. Largest number will be the HCF. So answer for this question is 5. Answer for this question is 5. So if numbers are there, take the difference between the two numbers. Take the difference between the two numbers. I hope it is clear, right? Take the difference between the two numbers. What if 3 numbers are there, 4 numbers are there? Everything we will discuss once we understand this concept. So please write down this key point. HCF of A comma B. If I want to find out the HCF of A comma B, answer is an element. Answer is an element in the set factor of B minus A. If B is greater than A. HCF of any two numbers, answer is nothing but element in the set factor of their difference. Element in the set factor of their difference. Another important concept. Element in the set factor of their difference. Suppose if 3 numbers are there. Suppose if it is 24, 36 and 18 is there. 24, 36. 24, 36 and 18. If 3 numbers are there, what you do is, what is the lowest number? 18. What is the highest number? 36. Lowest number is 18. Highest number is 36. Take their difference. Factor of 36 minus 18 is 18. What are the factors of 18? 1, 2, 3. 6, 9, 18. 1, 2, 3, 6, 9, 18. Check with the largest. Is 18 dividing every number? 18 ones are 18, 18 twos are 36. It is not dividing. Is 9 dividing every number? 9 twos are 18, 9 fours are 36. Is 6 dividing every number? 6 threes are 18, 6 six are 36, 6 fours are 24. Answer for this question is 6. Answer for this question is 6. If more than 2 numbers are there, take the lowest number present in the set. Take the highest numbers present in the set. Take the difference between the 2 numbers. Take the difference between the 2 numbers. Take the lowest number and take the highest number. Determine the factors for the difference between the lowest number and the highest number. Lowest number and the highest number. I hope it is clear. I hope it is clear. Now we will solve some very good problems based upon whatever we have discussed. Rashid, I already told you HCF of 2 consecutive even numbers is 2. If it is any other even number, if it is suppose HCF of 20, 24, it is there. 2 even numbers. Take the common factor out beta. 4 into 5 and 4 into 6. 4 is taken out. HCF of 5, 6. So, co-primes HCF is 1. 4 ones are 4. This is how you do HCF of even numbers. HCF of even numbers. 2 important key points which I am repeating is factor of the difference method, factor of the difference method, point 1, point 2, HCF of A comma B is also equivalent to HCF of A comma A plus B. It is also equivalent to HCF of A comma B minus A if B is greater than A. Third key point, HCF of two consecutive even numbers. Two consecutive even numbers is 2. HCF of 1 with any natural number. 1 with any natural number is 1. HCF of two consecutive natural numbers is 1. Please write down these 3 important key points. HCF of two consecutive even numbers is 2. HCF of 1 with any natural number is 1. HCF of two consecutive natural numbers is 1. Shivashakti, right? Shivashakti, which can you please take an example? Narendra, HCF of two consecutive odd numbers. Two consecutive odd numbers is always 1. We have already written HCF of 5 comma 7 1. HCF of 11 comma 13 1. 11 comma 13 1. 11 comma 13 1. I hope it is clear till here. Please reply in the live chat if it is yes. If it is yes, 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 I will go to problems. Very, very good problems we are going to solve. You will fall in love with the way I solve HCF for a extremely difficult numbers. I will solve it in seconds. I will solve it in seconds. I will solve it in seconds. Is this clear to you? The funda of HCF, is it clear to you? Everybody kindly reply it in the live chat if the funda is clear to you. If the fundamentals are strong to you, then problem solving becomes extremely easy for you. And the best thing about our class is we will cover every possible model from a topic, from a very basic definition to an advanced level. Every model we will cover in detail. In detail. Suresh, the answer for your question is 1. 11 comma 15. Take the difference, Suresh. 4. 4 factors are 1 and 4. 4 will not divide 11. 4 will not divide 15. Now, these are all the problems which we discussed. Now, see HCF and its applications. Model 1. Please write down, sir. HCF and its application. Model 1. HCF and its application. Model 1. I will try to solve the problem in multiple angles. First question. HCF of 3 power 2007 minus 1 comma 3 power 2007 plus 1. Method 1. Method 1. Method 1. What is that concept which we discussed? HCF of A comma B is also equivalent to HCF of A comma B minus A. If B is greater than A. If B is greater than A. I will use this model. HCF of 3 power 2007 minus 1 comma 3 power 2007 plus 1. It is nothing but HCF of 3 power 2007 minus 1 B minus A. 3 power 2007 plus 1 minus of 3 power 2007 minus 1, which is 2. Already we discussed, right? These 3 power 2007 is an odd number. 1 is also an odd number. Odd minus odd is an even number. HCF of 2 with any even number. Answer is always 2. 2 with any even number, answer is always 2. So the first one, according to method 1, answer is 2. HCF of 3 power 2007 minus 1, comma 3 power 2007 plus 1. There are two numbers is given. Method 1, we discussed HCF of A comma B is HCF of A comma B minus A, which is nothing but congruence modulo theorem. Congruence modulo theorem. 3 power 2007 minus 1, subtraction of A from B, I got 2. 2 with any even number, HCF is 2. 2 with any even number, HCF is 2. Method 1. Method 2. Method 2. Method 1, I hope it is clear. Method 2. Method 2. Right? Akbar, you are right. HCF of co-prime should be 1. Where did I not took 1? Where is your doubt? Where are the numbers co-prime in this example? Right? Method 2. Method 2. Kirtana, you are not listening properly. What did I say? It is B minus A. What is B minus A? 3 power 2007 plus 1 minus of, how we got this? 3 power 2007 plus 1 minus of 3 power 2007 minus 1, which is 2. Right? Is it clear? Method 2. Method 2. Method 2. Number tree method. Number tree method. What is a number tree method? 3 power 2007. Odd power any number is odd. Odd minus 1. Odd minus 1 is an even number. Odd minus 1 is an even number. 3 power 2007 plus 1. This is an odd number. Odd plus 1, it is an even number. If you observe, even number, even number. What is the difference I got? 2. HCF of 4 and 6. There is a difference of 2. What is HCF? 2. HCF of 20 comma 22, which is again 2. What is that we discussed? HCF of 2 consecutive even numbers. HCF of 2 consecutive even numbers. It is always 2. Please write down. HCF of 2 consecutive even numbers. It is always 2. HCF of 2 consecutive even numbers is always 2. 3 is an odd number. Odd power any number is an odd number. Odd minus 1 is an even number. This is an odd number. Odd power any number is an odd number. Odd plus 1 is an even number. These two are consecutive even numbers. Consecutive even numbers, HCF is 2. Method 2, by using number tree method. Number tree method, answer is 2. Yes, Shiva Shakti, there are a lot of more problems are there. I will tell it. Everything will be crystal clear to you. Right? Method 2. HCF of any two consecutive numbers. HCF is 2. Method 2, I hope it is clear. Method 3. Method 3. Method 3, which is the best method. Method 3. What is method 3? HCF of A comma B, which is nothing but an element in the set. Which is nothing but element in the set, factor of B minus A. Element in the set, factor of B minus A. HCF of 3 power 2007 minus 1, comma 3 power 2007 plus 1. Take the difference. Difference is 2. How you got 2? 3 power 2007 plus 1 minus of 3 power 2007 minus 1. Take the factors of 2. What are the factors of 2? 1 and 2. What are the factors of 2? 1 and 2. This is odd minus 1, even number. Odd plus 1, even number. HCF of 2 even numbers is always an even number. Therefore, the answer is 2. All the three things which I discussed in basics, I used this in the problem solving. Method 3 is HCF of A comma B is element in the set factor of B minus A. Method 1 is congruence modulo theorem. HCF of A comma B is HCF of A comma B minus A. Method 2 is a number tree method. What is a number tree method? Find out the nature of the number, whether it is odd or even. Method 3 is HCF of A comma B is element in the set factor of B minus A. Element in the set factor of B minus A. Method 1, method 2, method 3. Method 1, method 2, method 3. Now we have got 1, 2, 3, 4, 5, 6. 6 examples I got. All these 6, I will create 4 more examples. 4 more examples. Total 10 examples I will give, so that this concept will be crystal clear to you. Crystal clear to you. Just to keep on listening, sir. 10 examples I will do in this type. 10 examples I will do. Not a single doubt you will get in this class. Generally in my class, if you diligently listen to every statement of mine, you will not get any doubt. Now, one by one, we will do. Example 1. Listen carefully to every example. Shakti, I will discuss your doubt here. HCF of 5 power 43 minus 3, comma 5 power 43 plus 3. HCF of 5 power 43 minus 3, comma 5 power 43 plus 3. I will use method 3 right now. It is nothing but factor of their difference. Difference is nothing but 6. What are the factors of 6? 1, 2, 3 and 6. 1, 2, 3 and 6. 5 power 43. 5 is an odd number. Odd number power any number is odd. 3 is an odd number. Odd minus odd is even. 5 is an odd number. Odd number power any number is odd. 3 is also an odd number. Odd plus odd is even. HCF of 2 even numbers is always an even number. Answer should always be an even number. Answer should always be an even number. Answer should always be an even number. So 3 is out. If a number is not divisible by 3, how can it be divisible by 6? So if whenever I am eliminating 3, automatically 6 is going out. Why? Because 6 is derived from 3. 2. 2 will divide both the numbers. 1 will divide. Largest number is 2. So answer for this question is 2. Answer for this question is 2. I hope it is clear. Sir, here you might misunderstand my statement. I said HCF of 2 even numbers is even. It cannot be odd. So 3 is eliminated. If 3 is eliminated, automatically 6 is eliminated because 6 is derived from 3. Out of 1 and 2, which is highest? 2 is highest. So answer is 2. We will do one more example. We will do one more example. Till it is completely clear to you, I will create as many questions as possible. Example 2. H.C.F of 9 power 143 minus 5, comma 9 power 143 plus 5. 9 power 143 minus 5, comma 9 power 143 plus 5. Immediately it should come to your mind. It is nothing but the factor of their difference. Factors of 10. 10 factors are 1, 2, 5 and 10. 1, 2, 5 and 10. Now if you see here, 1, 2, 5 and 10. 9 is an odd number. Odd minus 5 is an odd number. 9 is an odd number. 5 is an odd number. Odd minus odd is even. Odd plus odd is even. HCF of even numbers is always even. Answer should be an even number. 5 is out. If 5 is out, automatically 10 will be out. Largest factor which will divide is 2. Largest factor which will divide is 2. Two examples. I am sure everybody understood how to do factor method to get the HCF very fast. How to do factor method to get the HCF very fast. Now, first one answer is 2. Second one answer is 2. Now, before we solve this third example, HCF of 2 power 4 minus 1, comma 2 power 6 minus 1. 2 power 4 minus 1, another variety, comma 2 power 6 minus 1. Method 1. Method 1. Method 1. HCF of A comma B. Answer is nothing but a element in the factor of B minus A. So this is nothing but factor of their difference. Factor of 2 power 6 minus 1 minus of 2 power 4 minus 1. This is factor of 2 power 6 minus 2 power 4, which is nothing but factor of 2 power 4 into 2 square minus 1. 2 square minus 1. 2 is an even number. Even number minus 1, odd number. Even number minus 1, odd number. HCF of any two odd numbers, answer will be an odd number. Answer will be an odd number. HCF of any two odd numbers, answer will be an odd number. 16 is an even number. Odd number is 2 square minus 1, 3. Check whether 3 will divide this number. 16 minus 1 is 15. 15 is divisible by 3. 64 minus 1 is 63. Is 63 divisible by 3? Yes. So answer for this question is 3. This is by using method 1. What is method 1? Method 1 is HCF of any two numbers. Answer is an element in the set. Factor of their difference. HCF of any two numbers. Answer is an element in the set. Factor of their difference. I hope the idea is clear. I hope the idea is clear. Third one, I hope it is clear. SV Tech, I am starting from basics and I am going level by level. Suddenly if you ask a question and ask me to solve it, I cannot do it because I am not your private tutor. I have to take care of all the students, every student who is not good in maths to a student who is brilliant in maths. All the levels I will take care, right? So factor of b minus a, 2 power 6 minus 2 power 4, right? Next one, method 2. HCF of 2 power 4 minus 1 comma 2 power 6 minus 1. Anil Nair's logical way. Anil Nair's logical way. So, because both of them are from 2 power, take the HCF of the powers. 2 power, HCF of 4 comma 6 minus 1. 4 and 6 is 2. Answer is 2 square minus 1. 2 square minus 1, which is 3. Students are not, see in method 1 you are not understanding HCF of their difference. 2 power 6 is 2 power 6 minus 2 power 4. HCF of 2 power 4 into 2 square minus 1. What did we just discuss? 2 power 4 minus 1. Even minus 1 is odd. 2 power 6 minus 1. Even minus 1 is odd. HCF of odd numbers is always an odd number. HCF of odd numbers is always 3 power 15 minus 1. 3 power 25 minus 1. I want the HCF. You don't need to do anything. Both are of the same power. 3 power of HCF of 15 comma 25 minus 1, which is 3 power 5 minus 1. Which is 3 power 5 minus 1. HCF of 11 power 12 minus 1. 11 power 18 minus 1. If the powers are same and both are behaving in the same pattern, it is 11 power 12 and 18, HCF is 6. Answer is HCF of 12 comma 18, it is 6. 15 comma 25, HCF is 5. HCF is 5. 3 power 5 minus 1, 11 power 6 minus 1. I hope the idea to solve this question is clear to you. Let me solve a few questions. Third question, or this question, what will be the answer? 3 power 6 minus 1, 3 power 9 minus 1. Answer is 3 power 3 minus 1. How you got 3? Which is the HCF of 6 and 9. 6 and 9, it is 3. 6 and 9, it is 5 power 24 minus 1. 5 power 36 minus 1. 24 and 36. HCF is 12. 5 power 12 minus 1. F of 2 written 4 times and 2 written 6 times. 2 written 6 times. 2 written 4 times and 2 written 6 times. How to determine this answer? Method 1. Then I will tell you Anil Nair's way of solving. Method 1. This is nothing but, can I write it as 2 by 9 into 4 nines, comma 2 by 9 into 6 nines. Can I write it like 9 will go 4 times, 2 into 4, 2 into 6 times. This is also HCF of 2 by 9 into 10 power 4 minus 1. 2 by 9 into 10 power 6 minus 1. So these are nothing but a factor of their difference. What is the factor of their difference? 2 by 9 into 10 power 6 minus 1, 10 power 6 minus 1 minus of 10 power 4 minus 1. Plus 1 minus 1 cancel. It is factor of 2 by 9 into 10 power 6 minus 10 power 4, which is 2 by 9 into 10 power 4 into 10 square minus 1. 100 minus 1 is 99. I will get factor of 22 into 10 power 4. 22 into 10 power 4. This step is clear, right? 2 by 9 into 4 nines, 2 by 9 into 6 nines, 2 by 9 into 10 power 4 minus 1. These 10 power 6 minus 1. 2 by 9 into 10 power 6 minus 1 minus of 10 power 4 minus 1. 2 by 9 into 10 power 4 common, 10 square minus 1. 100 minus 1 is 99. So remaining is factor of 22 into 10 power 4. I will write down in the next slide neatly. Factor of 22 into 10 power 4. Factor of, what is the final answer we got? H.C.F of 4 2's, comma 6 2's. This is nothing but factor of 22 into 10 power 4. 22 is 2 into 11 into 2 into 5 power 4. I want the factors of this number. This is an even number. This is also an even number. HCF of even numbers is always an even number. So answer definitely 2 will be there. Answer definitely 2 will be there. Next one, if you see here, what is the divisibility rule of 11? Divisibility rule of 11 is sum of the odd places, sum of odd places minus sum of even places should be divisible by 11. Should be divisible by 11. 2 plus 2 4, 2 plus 2 4, 4 minus 4 0, 4 plus 2 6. This is also 0. That means it is divisible by 11. It cannot be this answer. Why? Because for a number to get 10 power 4, it should be divisible by 2 power 4 and it should be divisible by 5 power 4. It cannot be divisible by 16, because for a number to be divisible by 16, it should be divisible by 8 or it should be divisible by 4. 22 is not divisible by 4. So answer for this question is 2 into 11, 22. There is a reason why I wrote it as 2 by 9 into 4 nines. There is a reason why I wrote. I will explain that reason. I hope it is clear. Answer for this question is 22, which is a traditional method 1. Method 2, we will discuss it. I hope it is clear why it should be. Why it should be 2? Because it's an even number. It's an even number. HCF of any two even numbers is even, which is 2. Why it is 11? Because it is satisfying sum of odd places minus sum of even places. Sum of odd places minus sum of even places. Why this is not possible? Because they are not divisible by 2 power 4 or 5 power 4. I hope it is clear. Method 2. Method 2. HCF of 2 2 2 2 2 2, comma 2 2 2 2 2 2 2. Here method 2. Anil Nair's logical way. Anil Nair's logical way. Here 2 is written how many times? 4 times. Here 2 is written how many times? 6 times. 4 times 6 times. What is the HCF of 4 times and 6 times? 4 times and 6 times is nothing but 2 times. Which number is getting 4 times or 2 times? 2. So 2 is written 2 times. 2 is written 2 times. Subtracting this number from this number and doing it, you might not understand it, how 22 came into picture. That is the reason slowly I did 2 by 9 into 4 nines, 2 by 9 into 6 times. This is written 4 times, this is written 6 times. So 4 times 6 times HCF is 2 times. So answer is 2 is written 2 times. Now you might ask me in the previous question, why this method 2 is working? Like one student asked me, right? Proof for method number 2. Deepshika, directly you cannot subtract it. Explanation might go for a toss, right? Next one. Method 2 for the previous question. HCF of 2 power 6 minus 1, comma 2 power 9 minus 1. Directly what did I say? 2 power of HCF of 6 comma 9 minus 1, 2 power 3 minus 1. Proof for method 2. Proof for method 2. Proof for method 2. A power n minus b power n. A power n minus b, or well, let us take this example. A square minus b square is a minus b into a plus b. A cube minus b cube is a minus b into a square plus ab plus b square. A power n minus b power n is always divisible by a minus b if n is a natural number. Please write down. A power n minus b power n is always divisible by a minus b if n is a natural number. So here, if you see 2 power 6 minus 1, which is nothing but 2 square whole cube minus 1 whole cube, 2 power 9 minus 1, which is, or I will write 2 cube whole square, 2 cube whole cube minus 1 cube. A power n minus b power n is always divisible by a minus b if n is a natural number. So this is divisible by 2 cube minus 1. This is the proof. A power n minus b power n is always divisible by a minus b if n is a natural number. 2 power 6 minus 1 is 2 cube whole square minus 1 whole square, or 2 cube whole cube minus 1 whole cube. So both are divisible by a minus b. A minus b. I hope it is clear. A minus b. Navneet, you can watch the class again after the class is over. After the class is over, so that, right, few days I will keep some topics public. Few days only I will keep. Sir, I want the entire comprehensive course. We are running a super 50% discount. Night close to 23 students have purchased. I'll still continue the offer so that you can save a lot of money. Right? A power n minus b power n is divisible by a minus b if n is a natural number. Some more examples. HCF of 7 power 28 minus 1, 7 power 35 minus 1. 35 minus 1. What is the answer? 7 power of HCF of 28 comma 35 minus 1, which is 7 power 4 minus 1. What is the proof for this? 7 power 28 minus 1 is 7 power 4 power 7 minus 1 power 7. 7 power 35 minus 1 is 7 power, sorry, it is 7 fours. I hope it is clear, right? So 28 and 35, HCF is 7. Sorry, 1 minute. Right? So these is nothing but 7 power 28 minus 1. Here also it is 7 power 35 minus 1. A power n minus b power n is always divisible by a minus b if n is a natural number. I made a mistake here, calculation mistake. It is 7. It is 7 here. 7 power 28 minus 1. 7 power 28 minus 1. I think I have done. This is 7 power 7. These, sorry sir, what am I doing? HCF of, there is a mistake which I did in the previous question. 7 power 28 minus 1, comma 7 power 38 minus 1. 7 power 7 minus 1 is the answer. 7 power 28 minus 1 is 7 power 7 power 4 minus 1. 7 power 35 minus 1 is 7 power 7 power 5 minus 1. Previous question there is a mistake which I did it. Please kindly correct it. Right? I hope it is clear, right? 7 power 28 minus 1. See, I wrote 7. I am doing in the mind power to the power problems. I am doing in the mind power to the power problems. So, 7 power 7 power 4 minus 1, 7 power 7 power 5 minus 1. So, answer is 7 power 7 minus 1, right? There is a small calculation mistake which I did it. I hope you have understood the concept. Kindly reply it in the live chat if you have understood the concept. If you have understood the concept, kindly reply. Kindly reply. Niharika, what am I doing is, I am doing the HCF of 28 and 35. 28 and 35, I am doing it. I hope it is clear. Kindly reply in case if you have understood the concept. Calculation mistake, forget about it. Kindly reply. Now we will solve. Shekhar, I will discuss everything. Have some patience. Everything I will discuss. Negative powers also I will discuss. Charan, you can also use it in x power 5 plus 1. That also logic I will discuss. Just have some patience. Right? Now answers will be very, very easy to you. What is the answer for this question? Answer for this question is 5 power 12 minus 1. Answer for this question is 3 power 3 minus 1. Answer for this question is 2005, 2010. HCF is 5 times. So 4 is written 5 times. 12 times and 18 times. Answer is 6 times. 7 is written 6 times. 6 times and 9 times. 2 is written 3 times. Answer for this question is 2. Answer for this question is 2. All the problems, is it clear to you? 6 problems, is it crystal clear to you? Is it crystal clear to you? Is it crystal clear to you? Right? I hope it is clear. All the problems are clear to you. Every problem, is it clear to you? H.C.F, definitions, various methods to find out H.C.F and the problems. Everybody, is it clear to you? Is it clear to you? Because somebody has asked me whether it is x power 5 minus 1 or not. Please write down this point. A power n plus b power n is divisible by a plus b, is divisible by a plus b if n is an odd number. If n is an odd number. For example, a cube plus b cube is a plus b into a square minus ab plus b square. Right? Suppose if I take an example of 2 power 9 plus 1, 2 power 27 plus 1, HCF of 2 power 9 plus 1, 2 power 27 plus 1, 2 power 27 plus 1. This is factor of their difference. 2 power 27 minus 2 power 9. This is factor of 2 power 9, 2 power 18 minus 1. 2 power 18 minus 1. This is even. Even plus 1, it is an odd number. Even plus 1, it is an odd number. HCF of any two odd numbers, which is 2 power 9. 2 power 18 minus 1, which is nothing but 2 power 9 minus 1 and 2 power 9 plus 1. 2 power 9 minus 1, 2 power 3 minus 1 and 2 power 3 plus 1. This is remaining is 2 power 9 plus 1. Now see here. 8 minus 1 is 7. 7 will it divide this number? 512 plus 1 is 513. 7 is not divisible by this number. 7 is not divisible by this number. Out of these two, one among them is right. Out of these two, one among these right. So 2 power 27 plus 1 can be written as 2 cube power 9, 2 power 9 power 3 plus 1 power 3. A power n plus b power n is divisible by this number. So answer is 2 power 9 plus 1. So because of this logic, 9 27 HCF is 9. So answer is 2 power 9 plus 7 power 28 minus 1. 7 power 15 minus 1. I want to find out the HCF. 7 power HCF of 28 comma 15 minus 1. 28 and 15 are co-prime numbers. If co-prime numbers is there, what is HCF of co-primes? It is 1. 7 minus 1 is 6. 7 minus 1 is 6. 7 minus 1 is 6. I hope it is clear. Now, I hope it is clear. I will repeat the important key points. HCF, factor of b minus a, one method. Congruence modulo theorem, another method. HCF of consecutive even numbers, it is 2, another method. Another is HCF of p power, HCF of powers minus 1, another method. HCF of p, HCF of A times comma B times. A times comma B times. 1, 2, 3, 4, 5.